All right, we're going to continue looking at some um, logarithms and exponents. So these first ones want us to write in logarithmic form. Okay, so let's set up our triangle that's going to help us do this. 5 to the negative second power, 1 over 25. So if I want log base, I just use the bottom, or log form, I use the bottom. Log base 5 of 1 over 25 equals negative 2. Good. This conveys the exact same information as the exponent form. 4, 0, 1, that would mean log, so we use the bottom, the legs, log base 4 of 1 equals 0. 10 to the third power equals 1,000, so 10 to the third is 1,000. If I want the log, I use the legs, log base 10 of 1,000 is equal to 3. All right, now we want to write an exponent form. All right, so we're given log form, so we'll write the legs, 3 and 7, and that's x. So that must mean that 3 to the x power is equal to 7. All right, now number 5, this is one we haven't seen yet. You'll notice that there's no base for the logarithm. It just says log. Uh, a lot of times in math, we have stuff that has invisible numbers, and this is also the case. Whenever you see a log that's by itself, it's a base of 10. Okay, so a log without a number under it is implied to be a base of 10. Okay, so what we're looking at is 10m and n. Log base 10 of m is equal to n. So that must mean that 10 to the n power equals m. All right, and now we have to evaluate. All right, so let's take a look at this. Number 1. So remember, we're going to basically set up an equation that will help us solve this. So we're just going to say log base 1 over 49 of 7 equals x. So that would mean, so 1 over 49, 7x. So that would mean I'm looking at 1 over 49 to the x power equals 7. So the first thing I need to do is write them as the same base. So 1 over 49 is 7 to the negative second power. And this is 7 to the first power. If I multiply those, I have 7 to the negative 2x equals 7 to the 1. And now they have the same base, so I can just set the exponents equal to each other. Negative 2x equals 1. Divide by negative 2, x is equal to negative 1/2. So that must mean that if I go back up here and I evaluate this, this is equal to negative 1/2. Number 2, log base 256 of 1 over 32. All right, so 256, 1 over 32, and I'm trying to figure out what this evaluates to. So I'll say 256 to the x power equals 1 over 32. All right, I need to write these both as powers of 2. All right, so if I write 256 to the power of 2, I think it's 2 to the 8th power. Yes, 2 to the 8th power. So this would be 2 to the 8th. And this is 2 to the negative 5th, because 2 to the 5th is 32, so 2 to the negative 5th is 1 over 32. All right, so this is 2 to the 8x equals 2 to the negative 5th. So I can just set the exponents equal to each other. 8x equals negative 5. Divide by 8. X equals negative 5 over 8. All right, so when this evaluates to negative 5 over 8. All right, and then number 3, log. So remember, we're looking at a log with a base of 10, 0.001. All right, now there's a couple ways to do this, but the best way to do this is to rewrite that as a fraction. So that is 1 over 1,000. The reason for this is now I can write it as an exponent. So this is 10, this is 1 over 1,000. And remember, I'm trying to evaluate this, so I'm essentially going to solve it, or figure out what x is. So if I write this as 10 to the x equals 1 over 1,000. So remember, we need to give these the same bases. So this is 10 to the x, and this is 10 to the negative third. Okay, 'cause 10 cubed is 1,000, so 10 to the negative 3 is 1 over 1,000, which means that x is equal to negative 3. So I can just say that this is equal to negative 3.